Let's look at the four forces on an airplane. First of all, force is a vector quantity, so it has a magnitude and direction. Now, let's start off with the first force that acts on an airplane. Weight. Weight is a force that is directed toward the center of the earth. The magnitude of the weight depends on the mass of all the airplane parts, plus the amount of fuel and also payload on board. We can think that all the weight is collected and acts to a single point called the center of gravity. During a flight, an airplane's weight constantly changes as the aircraft consumes fuel. The distribution of the weight and the center of gravity also changes, so the pilot must constantly adjust the controls to keep the airplane balanced. Now let's start with the second force, lift. Airplane generates its opposing force so it can overcome the weight force. Lift is generated by motion of the airplane through the air and its aerodynamic force. The word aerodynamic stands for, let's start off with the aero. Aero stands for the air, and dynamic stands for motion. Lift is directed perpendicular to the flight direction. The magnitude of the lift depends on several factors, including the shape, size, and also velocity of the airplane. Most of the lift is generated by the wings, and aircraft lift acts to a single point called the center of pressure. The distribution of lift around the aircraft is important for solving the control problem. Aerodynamic surfaces are used to control the aircraft in roll, pitch, and yaw. The third force is drag. Drag in the airplane travels through the air. There is another aerodynamic force present. Air resists the force of the airplane, and the resistance force is called drag. Drag is directed along and opposed to a flight direction. The shape of the aircraft, the stickiness of the air, and the velocity of the aircraft are all factors that affect the magnitude of drag force. And drag acts to the aircraft center of pressure. And finally, thrust. To overcome drag, airplane uses a propulsion system, and this allows the plane to push off forward, generating a force called thrust. The direction of the airplane also depends on how the engines are attached to the aircraft. The thrust direction must be raised to help the airplane take off in a very short distance. Thrust depends on the propulsion system, including the type of engine, number of engines, and throttle setting. For jet engines, it is often confusing to remember that aircraft thrust is a reaction to the hot gas rushing out of the nozzle. And here is the nozzle of the aircraft. The hot gas that comes out the back, but the thrust pushes toward the forward. Action and reaction is explained by Newton's third law of motion. Now let's look at the vibration and sounds of an aircraft. There are a lot of different types of vibration that are created by an aircraft, and only minor vibrations are noticed by passengers. One common vibration that comes from an airplane is the flexing of the wings, and also some noise. But don't worry, guys, this vibration is perfectly safe. There are several causes of vibration in a modern aircraft, and most of them aren't even dangerous or unusual. For example, vibration happens during extensions and retraction of landing gear, aerodynamic brakes, takeoff, and also when landing. The engineers produced constant vibration because they are always working. Other vibration comes from the mass distribution by aircraft and the structural stiffness of an aircraft. And these are heard as background noises by passengers. Vibration can also get larger in turbulent or rough air, and passengers can actually feel them. Sometimes when the engines are operating at certain levels, increased vibration may occur due to resonance. This is normal and often sounds loud only because the waves are transferred through the frame of the aircraft to the ears of the passengers. Flight crew are familiar with normal vibrations. They notice the vibration using their senses. Just to be safe, engineers have put sensors in the engines in case of an abnormal vibration that can't be detected. Abnormal vibrations are easy to recognize because they have an unfamiliar noise. They can be steady or random, an obvious source, or difficult to recognize. Abnormal vibration can be caused by malfunction mechanical equipment, engine roller imbalance, irregular airflow, excessive wear, and free play. One example of an abnormal vibration is a buffet. Buffet is caused by an interruption in airflow. They're also felt when aerodynamic brakes are also used or when the plane flies through turbulence. In addition, a certain amount of noise is to be expected due to the operation of the engines. Aircraft noise is a vibration caused by the rapid back and forth movement of one part of the aircraft. The most dangerous type of vibration in an aircraft is an aeroelastic flutter. It is when the energy added to the vibration by the airflow around the wings of an aircraft is greater than the energy lost as a result of dampening the wings. If the wings last long enough and has a large enough aptitude, it can cause the aircraft to fail. To test for flutters, the first test is a pulse test. In this test, the pilot controls the plane so that the airflow is distributed around the wings. It is then monitored and steadied. Then it goes on to the sweep test. In this test, engines produce large computer-generated vibration in the wings, and to pass this, the flutter induced in the wings should dampen in a couple of seconds.